Hi everyone, my name is Miguel Escudero Abenza and I'm a local here from Orihuela. I'm a theoretical particle physicist and I work at CERN, the European Organization for Nuclear and Particle Physics Research, and I'm based in Geneva. But I'm here now on holidays in my hometown and I'm here at the Munich Museum. And as I said, I'm a theoretical physicist and I work in cosmology, trying to understand what happened in the early universe right after the Big Bang. And these days I'm working quite actively on trying to understand why are we living in a universe with only matter and no antimatter. So we know for more or less 100 years that every particle that we know has a partner that is called its antiparticle, that is the very same but with the opposite electric charge. So for example, we have the proton that forms the nucleus, and the proton has a partner called the antiproton. Is identical to the proton, same mass, but with opposite charge. The proton is plus, the antiproton is minus. The same with the electron. We have the electron has a negative electric charge, but the electron has a partner called the positron, which has positive electric charge, but the very same mass. And they interact in the very same way. What is the cool story? If we extrapolate the universe that we observe back to the very early universe, we would expect the early universe to be a soup of particles where we should have the same amounts of matter and antimatter. If that were the case, then we should be living in a universe with the same amount of matter and antimatter. However, we don't live in such a universe, and we live in a universe where there is only matter. The key property of matter and antimatter is that when they collide, they annihilate and they produce radiation. So somehow, something in the early universe should have happened such that there was a bit more matter than antimatter in the early universe, in a way that in the early universe a cosmic battle was yielded, and only a small amount of matter remained, and this is what forms the galaxies in the universe we observe. So I do this research at CERN because everything that we learn about particle physics has direct applications to the very early universe. And this is all, and see you.